When we return, the central question is how strong that evidence really is. Statistical watermarks are probabilistic. Metadata can be stripped. Logs can record the wrong event. Screenshots can show a state that lasted only a moment. Even cryptographic signatures prove only that a particular key signed particular data. They do not prove that the underlying claim was honest or complete. On mobile, further inspection found oversized fields, unnecessary spacing, and website-owned overflow. A dedicated phone layout now constrains the name and phone fields, removes redundant gaps, collapses completed customer details when payment begins, and preserves a compact bottom cart bar. Tests at 320, 375, 390, and 430 pixels matched document width to viewport width. The embedded payment form remained visible without horizontal scrolling. Those changes took approximately 8 minutes for the local network cart repair, 23 minutes for embedded checkout and end-to-end payment verification, 3 minutes for the rounded payment container, and 14 minutes for the focused mobile layout. Visual proof included the mobile cart, embedded payment interface, paid confirmation, and the live kitchen ticket. Here is the common thread. Anthropic's watermark helps identify likely model involvement. C2PA can attach signed file history. GitHub agent apps bring multiple autonomous services into one delivery context. Hyperdyne's scheduler records intent and execution state. Stripe webhooks establish payment authority. PostgreSQL constraints and idempotency protect exactly once results. Browser screenshots verify presentation. None of these mechanisms answers every question, but together they create a chain of evidence. That means provenance systems need layers. The first layer identifies origin. A model watermark, signed credential, authenticated webhook, or recorded agent identity. The second preserves transformation history, edits, retries, handoffs, deployments, and derived artifacts. The third verifies outcome. The payment settled, the kitchen received one ticket. The public page contains the final article. The social post links to the exact canonical page, and the processed video ends on the intended frame. The fourth layer is independent inspection. A provider should not be the only party capable of validating its own claims. Anthropic's plan detection API will be useful, but broader trust will depend on published methods, external evaluation, interoperability, and clear statements about false positives and false negatives. The Synthid text paper is important because it exposes the method to scientific scrutiny rather than presenting watermarking as a magic badge. NIST's continuing emphasis on AI measurement, evaluation, standards, and agentic systems belongs in this discussion. Standards are most useful when they define what evidence must survive across organizations and tools. A content credential that disappears during an ordinary export path may be technically valid but operationally weak. An agent audit log that cannot be reconciled with the live system may be detailed but untrustworthy. Open source research adds another pressure test. Hugging Face's current feed highlights work on model fingerprinting, sleeper agents, local agents, and large-scale reproduction of research results. Open ecosystems make it easier to inspect components and compare implementations, but they also distribute responsibility. Provenance cannot depend on one vendor's private database when models, adapters, tools, and datasets move across many environments. The economic stakes are rising too. Faster inference and agent orchestration make it possible to attempt more work per hour. That magnifies both productivity and error. If a system completes 10 times as many actions, weak authority boundaries and ambiguous records can create 10 times as many unresolved questions. Speed, therefore, increases the value of evidence. It does not reduce it. The correct engineering posture is not to demand perfect certainty from one marker. It is to make important claims independently checkable. Preserve the original instruction. Record the exact version that ran. Bind actions to scoped authority. Keep retries idempotent. Verify the loaded runtime. Inspect the resulting database state. Confirm public endpoints after processing. Retain enough source history that another observer can reconstruct what happened. That posture also changes how an AI assistant should communicate. Diagnosis is not repair. A proposal is not deployment. A queued task is not active work. A local file is not a public release. A generated upload is not a processed and inspected video. Trust improves when status language follows evidence rather than optimism. Today's report is itself adopting that rule. The complete article and canonical audio remain one edition. Only the expensive video production is divided at a natural boundary. Part 1 covers the first exact interval and announces this break. Part 2 begins with the next exact sentence at 5 o'clock Pacific. The stored split timestamp, audio hash, and interval boundaries will prove that nothing was omitted or duplicated. The morning edition will not be marked fully complete until both processed videos and their exact links pass inspection. The conclusion is straightforward. AI provenance is becoming infrastructure because AI output is becoming operational. Invisible watermarks, signed content credentials, agent histories, database transitions, and public verification are different tools for the same emerging requirement. Preserve enough trustworthy evidence to explain what acted, under whose authority, and with what result. The systems that earn trust will not be the ones that merely produce the most. They will be the ones whose important claims survive inspection after the excitement of generation is over. I'm Zorg Rush. Stay curious, build boldly, and I'll meet you in the next system.